Okay, so to go over some additional examples from the topic of number classification that we had started in class the other day, we had begun, I'm going to redo the couple that we did in class, negative 2.1 as an example, where they would go, where they would fall in the Venn diagram. The number negative 2.1 is a decimal, and so it's just rational. The number negative 12 is an integer, and it's rational, and it's real, but it's not a whole number because whole numbers can't be smaller than 0. Another example we did was the square root of 81. Well, the square root of 81 is really 9, so 9 is a natural number. And by putting it there, you're saying that it's natural, it's whole, it's an integer, it's rational, and it's real. Next example would be the square root of 12. And now you could feel free to pause the video and see if you know where it would go. Square root of 12 would fall under irrational. It's not a perfect square, 12. So when you take its square root, the answer will be irrational. Another example, 8.666 repeating. Take a minute and see if you know where it would go. And that would be rational. All repeating decimals are rational because they come from fractions. When you divide certain fractions like 1/3, 2/3, they are repeating decimals. Here's another example, 2/3 pi. So although 2/3 is rational, pi is irrational, so 2/3 pi would fall under irrational. Another example, 20/5. So 20/5, 20 is divisible by 5, so you can simplify this to just the number 4. And the number 4 is natural, and it's whole, and it's an integer, and it's rational. So you put 20/5 here in the center to say it's natural, it's whole, it's an integer, it's rational, and it's real. So sometimes they tell you to list the categories, all the categories that a number belongs to, and so you would list all of those. And we'll do 2 more, negative square root of 100. This can also be simplified as just the number negative 10. Square root of 100 is 10, so and there's a negative in front, so negative 10. Negative 10 is an integer, so negative square root of 100 would go right there. And finally, the last example, 3.7984. 3.7984 does not go on forever. It terminates, and so therefore it's rational. So it would go out here, 3.7984. Okay, thanks.